Hello, this is John Atkinson from Test Products International, and in this short video I'm going to be talking about condition-based maintenance, what it is and why you should be using it. But very simply, CBM involves monitoring the condition of your machinery and only doing something when it needs doing. So this obviously involves monitoring the machine condition, in other words, taking measurements. More about this later. Probably the easiest way to talk about the benefits of CBM is to start from the perspective of what maintenance techniques are available, what has been used in the past, what's available now, and what's coming in the future. And this study that was carried out by the EPRI has shown a cost for the maintenance program. This is just the maintenance. This ignores any obvious benefits that you get from CBM of increased uptime, but we'll come to that later. If we just look at the cost of doing something called reactive maintenance, in other words, breakdown maintenance, run something till it breaks down, then fix it. Then we came up with a cost here of $17 per horsepower per year just to run the maintenance program. I mean, this is what people did before they had any alternatives. This cost, however, reduces if you go to a planned periodic maintenance program, PPM. And this is what people have mostly done because there is nothing else available. It's what you do for your automobile or for planes, that kind of thing. But if you can go to CBM and actually monitor the condition of your plant, then you get this very significant cost saving, a factor of 2 on this particular study. What's interesting to note is that a similar study done in Europe by a Swedish vibration consultancy showed that a figure of 22 euros per kilowatt per year was arrived at with breakdown or reactive maintenance. These figures equate very well to dollars per horsepower per year, so it looks as if the two studies were broadly in the same area of cost, which gives us some degree of confidence. But what's more important is not the overall cost, it's the reduction in cost that you get when you move from breakdown maintenance to PPM and then to CBM, and even more dramatically if you move to something called proactive maintenance. And I'm going to say more about that later, what that involves. But you can see there's now a 4-fold reduction in cost. This is just the cost of implementing the maintenance strategy, remember? But that factor alone of 4 times cost reduction means we really should be looking at these smart maintenance techniques compared to running it till it breaks down or periodically stopping it and taking it apart and having a look. Okay, let's go through each of the techniques in turn. Reactive or breakdown maintenance, also known as firefighting. I mean, if you run something till it breaks down, not only can it cost you many times more to repair it after the breakdown, you've also got health and safety implications. Would somebody have got hurt by that breakdown, for example, is a very significant factor to take into account, as is the lost downtime, because it's also going to take you a lot longer to repair the equipment after an unexpected breakdown. Okay, if we then move to PPM, there is a big disadvantage, and that concerns the difficulty of deciding how often do we take it apart and have a look. Well, if we do it too often, then we're wasting effort. We're taking things apart that are perfectly okay. If we don't do it often enough, then we're back to breakdown maintenance. We get unexpected breakdowns with the health and safety implications and the much higher cost of repair after that breakdown. We also have to make sure that we carry our spares so that when something does break down, it can be repaired. But this means carrying a lot of redundant stock, so that when we take something apart, realize it needs fixing, if we haven't got the spare, then we're going to have to wait and incur downtime until we can get those spares ordered. And the other factor is that if we take something apart, we're also likely to introduce an error, a fault, a breakdown. And this comes from the well-known bathtub curve, shaped like a bathtub, hence the name. This is telling us that during the startup period, we're far more likely to have a fault. So as the thing runs in and the startup period gets to the useful life period of the machinery, we are into an area of low fault probability. But then we hit the wear out period, and then the probability of a fault goes up with time. What we want to do with CBM is run as long as we can in this useful lifetime, and when we see this period here, when we see wear occurring, and this comes back to the measurement of condition, then we stop and go back to this point here. PPM, we go somewhere along this useful life. How far? Difficult to decide, like I said before. But if we're only to here, we're constantly taking it back into the startup period and risking higher fault probability. Now we come to CBM. And the whole point with CBM is we don't waste any effort taking machines apart that don't need it. We only repair the machines that actually need repair. We spot the faults before they cause the breakdown. The machine condition tells us when it's going to break down, and we can do something about it before it breaks down. We can then plan the work to repair the machine, and we can order our spares in advance. We can coincide with shutdowns, and we can most of all reduce downtime. And that's the biggest benefit of CBM. It's not only a cheaper way of doing things, it gives us this very significant cost benefit. And again, more about that later. Now, there's always got to be a disadvantage to everything. And the disadvantage of CBM is we've got to buy equipment to allow us to measure and monitor our machinery. Things like vibration analyzers, thermal cameras, and trending software. And we also got to train our maintenance personnel how to use these tools. And at one time, the tools were difficult to use and expensive. So the training involved was quite significant, but not anymore. These tools are now available at low cost, and they're very easy to use by even the most junior technicians would be able to use a vibration analyzer or a thermal camera with minimal training. Most of it's intuitive. Okay, now we come to the area where you really get the cost savings, and that's proactive maintenance. In other words, we close the loop. We find the root cause of the problem and we correct the root cause so that the problem doesn't keep occurring. And in order to do that, we need to monitor a lot of things so that we can actually find out what is the root cause. The best way to explain this is to give a very simple example. Let's suppose we buy a bearing and the manufacturer tells us that the lifetime of this bearing is approximately 5,000 hours, but then it wears out after 3,000 hours. Okay, we could just replace the bearing. But why did it wear out prematurely? Was it because the machine was out of balance? Was the machine out of alignment? Or have we got a lubrication problem? A lack of lubrication, or the lube is sticking somewhere and not actually reaching the bearing? You know, there's a blocked grease nozzle or something like that. And this is the root cause that we need to fix. So we need to balance the machine, make sure it's aligned properly, and make sure we lubricate the bearing properly, and then we'll get our 5,000 hours and not have to keep replacing bearings prematurely. This is proactive maintenance. Okay, what do we have to do? Well, we have to basically monitor what's going on. We need to listen to things, we need to observe things, measure, monitor and record. And this, these days, involves software. So what can we do? Well, we can measure vibration very easily, temperature, we can make lubrication measurements, we can record those details, and we can study the trends. This is important. It's all about, is something getting worse or is it staying at the level we want it to? Think of the bathtub curve. Are we in that nice flat level where nothing's changing, everything's happy, the machine's okay, leave it alone. As soon as we start to see a trend where something's increasing, the vibration's increasing, the temperature's increasing, the viscosity of the lube is increasing, then we know something's going on. That's the point where we need to step in and do some maintenance. Okay, so just to summarize that, we know that we get these cost reductions in the actual cost of the maintenance technique that we're implementing. So in other words, proactive maintenance programs cost us a lot less than reactive maintenance programs. Well, here we've basically got people running all over the factory trying to put out fire. Here we're planning it, we're reacting to things that are the root causes and fixing those root causes so we get the best performance from our machinery. However, the biggest cost benefit of CBM, the true cost, is less downtime. In other words, we have lower breakdowns. And a good example of this cost is the opportunity cost. For example, if a food or drink supplier loses their supply, they may lose their place in the supermarket. They lose shelf space to a competitor, and this means that they have trouble getting the shelf space back. You've got to wait until the competitor product's been sold, and in the meantime, your customers are buying your competitor's product. They're actually being encouraged to switch brands. So a simple disruption in the supply chain from an unexpected breakdown can have huge implications for your cost in the longer term. Okay, why do faults occur? Well, obviously, things wear out. That's just physics, if you like. Wear is inevitable. We can reduce it, we can't eliminate it. Sometimes, as I mentioned before, lack of lubrication is common. Automatic greasers will stick. People will negligently omit to lubricate something or accidentally miss a lube, and the thing doesn't get its lubrication in time. We get corrosion, electrical faults. Vibration itself will work things loose over time, take things out of alignment. We get dirt build-up, or will take machines out of balance, for example. We very often find machines are overloaded or they're incorrectly used. A classic example of this is robots that are stopped using the emergency stop button instead of ramping them down slowly as you're supposed to do. That puts massive wear on the gearboxes and eventually causes faults. Okay, this is what I'm trying to avoid. Catastrophic bearing failure. You can see this has got very hot. It probably was quite dangerous when it failed, and it's unexpected failure. If we'd have spotted this bearing was going before it failed, we could have stripped this motor down, changed the bearing set front and back, and not had this problem. Can it be prevented? Yes. If we have an effective maintenance program, we can guarantee to reduce or even eliminate breakdowns. It's possible. People get in aeroplanes and trust to them, and we know that they could break down. But if you've got an effective maintenance program, they won't. Okay, so let's look at some strategies for CBM. And I'm going to go through each of these, but just to mention that by far and away, the most used method is vibration analysis. And I'll go through them all and talk a bit more about this in a sec. Okay, thermography, temperature measurement, very good way of finding things like three-phase faults. So there's an overload on a three-phase electrical supply here. You can see this one's getting hot. Here's a bearing that's hot. Either side of this coupling, this bearing is much hotter than this one. So here's your motor driving your pump or your fan. And you can, here again, a three-phase pulling more current out one of the phases. And the camera lets you get that overall picture of what's going on. So all these tools should be considered. These days, a low-cost thermal camera, €1,000, roughly $1,000, will get you a thermal camera that will give you this degree of resolution. You can go for ultrasound. Ultrasound's very good at picking up air leaks. It can also pick up bearing faults by listening effectively to the squeaking of the bearing. So if your bearing's not been lubricated properly, it will give out ultrasonic squeaks, and you can pick that up. It's not very discriminatory in that you can't tell the difference between an air leak and a bearing fault, but it's nevertheless a low-cost tool that could be used usefully in that way. Electric motor testing, there's lots of kits out now. We can use current clamps, voltage probes, and we look at things like winding current, rotor current, and we can pick up faults. So it is possible to actually determine if you've got a fault developing on your electric motor by monitoring things like rotor current, winding current, etc. Oil analysis. Well, traditionally people would smell the oil, look at it, test its viscosity, test its water content. And these days we can get some nice units. I mean, this one's under $2,000. And you put a sample of oil taken from the gearbox here into the machine, and it will tell you the ferrous content. In other words, any metal particles that are wearing in the gearbox will appear as debris in the oil, and you can monitor this. You'll get a readout of the parts per million of the metal in the oil. By far and away, though, the biggest or most popular method of condition monitoring is vibration analysis. Every rotating machine will give you a classic vibration signature, and if you measure that vibration and monitor it, you can tell things about the machine. You can say whether it's in balance, the degree of balance. You can say whether it's in alignment, if something is loose, and you can also tell the condition of the bearings. And you can monitor that bearing condition and determine when a bearing is going to fail based on the bearing signature that you get from its vibration pattern. Now, as I said earlier, that used to be a very expensive way of doing something, because the vibration analyzers, along with all the other measurement tools that I've just highlighted, were very expensive and quite difficult to use. But that's no longer the case. You can buy a vibration analyzer that will do vibration analysis. It will trend the readings. It will act as a data collector, so you can go out on a route and take measurements from a range of machines, bring it back and download it to your software running on your PC and get the trend, the all-important trend of the machine condition. These days, a vibration analyzer with the trending software included is round about €1,000, just over $1,000. Okay, and really there's no excuse now. CBM, the way forward. I'm hoping that after this short presentation you will agree with me that that is the way to go. Thank you for listening.